to look at different types of data supported by Weibull++. To do this, we create a new folio. So we go to Live Data, add new live data, and we have this setup, this data sheet setup that will help to define what type of data we're dealing with. So the first selection comes with the different types of data. We have a times to failure data or free-form data. For this example, we'll be using standard times to failure data, even though our units are not in time, but they are actually in kilometers. We have different units configured in the software, and if one unit, we are looking for some specific unit, we can always create our own unit. That's not a problem. Once we've done that, we have some options. That we can tick according to the exact type of data we're dealing with. The first option refers to write sensor data, and we use that when we, together with failure data, we've also got units that are still operating. So we click this option to indicate if units are operating, and we'll have to indicate whether in fact the number we insert is a failure, is an F, or it is a suspended, so in other words, it's still operating. The second option instead, it's another type of sensor data, but it's an interval type. So we have information on when it was last inspected, okay, and when we found it failed, okay, and when we found it failed. And the third option instead enables us to group the data, and we can see that in the example. So we're going to use all these three options, and we can see how our final sheet will look like. So we'll have 4 columns, plus we'll have a 5th column that will represent the subset ID that's always present. So we click OK, and that generates a new folio with these characteristics. So the first column is the number in state, and then we have the last inspected, then we have the state, failure or suspended, and then we have the final time, as well as the subset ID, which is a label that we may or may not use. So we're going to insert our data, and to better view our data, we just place some coloring, and the coloring will reflect the different types of data we're dealing with. So the first row, it's a failure, okay, and it's a failure where we know precisely where it happened, because the last inspected time coincides with the state and time, 13,047. So this is a complete data, okay. Then we have also another type of failure on row 4, but in this case is an interval data. In particular, is a left sensor data, because our product, our car, say, was new at time 0 we inspected, so when the car was sold, but we found a failure at 32,804. So this, in other words, was a hidden failure that was revealed only when the car went into a garage at 32,804 kilometers. So we don't know exactly where the failure occurred. We simply know this is the first service, and therefore it happened between 0 and 32,804. In blue, we got different types of failure. That's a typical interval failure, because in this case we have a time T1, 38,012, and a time T2, 42,500. So in other words, the failure occurred between this time T1 and a time T2. And then in green, we have a suspension. So in other words, we're telling the software that at 63,200, our car is still working, as far as the failure we're considering is concerned. So these are the 4 different types of data, and then we can see we also group some data. Instead of inserting 6 rows with the same numbers, we use this option to basically group our data. And obviously the software has to be able to analyze these different types of data, because these are the kind of scenarios we may be facing in a reliability analysis. And once we've done that, we can select a model that we consider more appropriate, and we calculate. Once we calculate, we generate the parameter of the model, and then everything else that follows is exactly like any other type of data analysis. So we generate our graphs, we can generate our graph of reliability, failure rate, and so on. And then, of course, we can interrogate. We can interrogate what is the, whatever, say, probability of failure at 10,000 kilometers, and so on. And that's it.